introducing to you Alishir Kurban. Alishir is professor at the Xinjiang Institute of Ecology and Geography. I have a personal link to him because we are working already 19 years together, almost 20 years. So he is working with GIS and remote sensing in desertic and semi-desertic regions, and he will present you today hydrology and climatology of salt lakes, development and use of appropriate models to safeguard water resources, impact of climate change. Alishir, the floor is yours.
Okay. Thank you very much, Mr. Chairman, and good morning, everybody. Should I sit down for speaking, or? Yeah, it's better. Okay, good. Okay, good. It's my honor to be here to give a little introduction about what we are thinking within the topic of our conference. And my title is about hydrology and climatology of salt lakes, development and use of appropriate models to safeguard water resources, impact of climate change. And some of my our work about the water remote sensing will be introduced and together with this topic. And my name is Alishir Kurban. You can call me Alishir. I'm a professor in the Xinjiang Institute of Ecology and Geography, Chinese Academy of Science. My research and teaching work is mostly focused on how to use remote sensing techniques for extracting the information about an arid land, and also using the GIS technology for geospatial modeling or database establishment like that. We also have a joint laboratory together with Philippe de Meyer within Ghent University, mostly focused on the research on the geoinformation application. And also one of the key laboratory from the local authorities located in our institute, and also mainly focused on developing the new remote sensing technology. And there's another one is Research Center for Ecology and Environment of Central Asia, which was funded by Chinese Academy of Science. And my institute is a leading institute of this research center, covering all Central Asian countries. We have a sub-center in Dushanbe, in Almaty, and also in Bishkek, and also some other field observation stations in Kazakhstan and also in Uzbekistan recently. Everybody knows about almost 70% of the Earth was covered by the ocean, and also some part of England territory also covered by the waters. And what we are focusing today is about an inland water, mostly focused about the saline water resources for Artemia. Then I looked at some recent research project, and but unfortunately about the gaining and the losing, only there is one paper existed in the 2016 about how much permanent water surface and also seasonal water surface is gained and lost in the past. All this work is based on the remotely sensed data and the integrated sum report. If we look at the salt lake distribution in the world, and then we can see, probably I can, if this, okay, it's, okay. So we can see there are a lot of, the famous salt lake was listed, and they are mostly being a resource for Artemia and some other perspectives. It is also the one of the main resource for aquacultural development. If we look at some statistics, and large salt lakes are 44%, and the large freshwater is about 50% like that. And so there are a lot of small lakes, and they are also considered as a resource for some arid land, specifically like over Hometown in Xinjiang. We don't have too much large lakes, but very few. And also there are a lot of report about the decline of the water areas, surface area, specifically like an drying up of an Aral Sea in the Central Asia. If you look at this, this is mainly contributed by drying up of Aral Sea for the surface water declining. And there are a lot of other reports also reported about the Dead Sea and the Great Salt Lake, and other salt lake is shrinking due to the various reasons, and some maybe about climate change and natural physical reason, and some of them is human activity caused reason probably. And recently there is one publication, and it's about a scientific data establishment for the global water pack. It's called the Global Water Pack Dataset. It is, the aims of this data is about an daily based worldwide mapping of the surface water, open surface water in the land actually. So the temporal resolution, they design it about on a daily, and the spatial resolution is about 250, mostly based on the MODIS-based data, and integrated some other data for detecting this water surface, and then analyzing about the variation of the water surface data. And if you're interested, you can visit the website, and this was already published in the scientific data. And if we look at about some models, and always we have a problem from the data and the precise data and for the supporting the models. And also if the model is too complicated, it's not easy to use it, and if it's too simple, and then the prediction is some problematic. So the precise data can create an accurate modeling, and also we have to consider about the difficulties and also the complexity of the model, and the easy to use, and some other consideration, and mainly about precise data. If we have an accurate, precise data, timely or say real time, and then we can have good prediction, and also the data support for planning our future. And what we can do, there are three types of observation everybody knows, like on the ground observation, specifically instrument-based measurement about all parameters what we need, and integrating with the remote sensing, and also modeling. And the remote sensing everybody knows, it's a good Earth observation tools, and it's like an extension of our eyes. And here I don't want to talk too much about that, but there are two keywords we have to consider about distance observation and non-touch physically, and from the ground-based, airborne, and also spaceborne. There are many platforms we can use. What we can get from this is specifically about the geographic location, and the shape and size, and the numbers of objects and quantity, and also the characteristics, like for example, for the water, we can say like a temperature of the water, and also some chemical component of like that. Also this will be characterized, affected, or say over this kind of mapping, and also affected by different characteristics of the remote sensors, like spatial resolution, temporal resolution, spectral resolution, radiational resolution, and also there's one new word, economic resolution. It's about money actually. And then we have this is why we use remote sensing. It's everybody knows it. And then we came to our research area in the Tarim Basin. It's one of the extreme arid zone in China, and the Tarim River is in one of the main river supporting all oases in this region. Then we looked at about an archaeology, archivings of the remotely sensed data for understanding about surface dynamics in this basin. If we look at, there are some small water can be identified. This is an AVHRR data. Then if we look at the archives of the remotely sensed data, we can get back to 1960s using the Corona satellite. And we also can see that some area like this Tetema Lake, I will talk a little later, and we also can see a lot of the water patches can be identified. If we look at the next, in 1960, you can see there are several water body can be extracted. Actually, they are also some of the lakes, and also they are also developing some aquaculture in this region. And this is in 2014. If you look at this part, and it's in the same area, there are a lot of new format, and the lakes are identified through the remote sensed data. This is a list of the data we are using from the 1970s. This is based on the Landsat data because it's available every year at least once or one or twice, and then it is make us possible to analyze about a yearly based variation of the water surface data here. And recently we have too many Landsat-like satellites available. So if we make like a virtual constellation, and we can observe or even 1 or 2 times of the data every day, and the similar like Landsat data. So it makes us to monitoring our objectives and quite like a near real time the manner or like that. So we this is our target area for developing several techniques for identifying, and also specifically for answering some question about this ecosystem. There is one ecosystem restoration project. So this is work based on that project to support and the effects of this kind of ecosystem restoration, including the wetland and also some temporal format and the water surface. Need to answer some question about should we keep this water, this temporal water surface or not. It is still a question from the decision makers for maintaining this ecosystem like that. Okay, this is before starting the ecosystem restoration. It's already dried up, and after that we have already some wetland is already recovered. And for detecting there's some technical details. I don't want to talk too much about that. And then we are trying to understand the history of this region, and we started to use not only the remotely sensed data like an aerial photography and also the satellite image, but also topographic map, which was made in 1950s, 60s, 70s, and in the different map scale. We also extracted all water information from that, including, then we integrated all data and together with the remotely sensed data. This is the satellite-based the water surface data for this region. And then we compared on some historical data, like Svenheden made a map for this region in 1899. And we have a topographic map for the 1959, and then we used the Landsat images to see how this water surface, or say the lakes, are changed in the history. And this is the final result. We noted that in some year, for example, like 2001, even we didn't have some much, and the smallest, I will say, smallest water surface was identified in 2001. It is just the beginning of this ecosystem restoration before it's already dried. And also we used simultaneous data after starting of this ecosystem project, and we looked at the variation of the water surface, look at in somewhere, this place was called Chivinköl. Köl means lake actually, but it's dried up, and then after this project it is recovered, but finally we didn't have too much water here, then support continuously, and later it's being the reed land here. It's actually being this vegetation patches actually after this restoration. And if we look at very frequent remotely sensed data for this study area from the 1970s, we can see many new lake was formed in this region. And then even in the recently we have a lot of new lake was formed here, and we used a frequent remotely sensed approach to check about when it was formed and how long it has existed. We are trying to analyze all history of the water patches here. For example, like here in 2002 and October 6, and there is no water. But after 2003, in the July, there is a new lake is formed. But in the August in 2000, and it's a little bit shrinked. And if you look at in 2010, it started to extend, and already have another one in the July in 2010. You see, it's this new one happened only like on 4 days, and in 2013, then only 1 day we got another extension of this lake. And all this lake water is already saline water, and now it's being a habitat of a lot of the birds, and also some kind of, I'm not quite sure it is what kind of Artemia, anyway, some kind of insects, or how to say, the Artemia-like things, and already discovered in this region. And now the question is, should we keep this water or not? Because if we want to keep it, we need to feed this lake, because a lot of evaporation there, so we have to keep some water to support for this lake. So we give them about what is happening in the history and what's happening recently and during the winter, and we also detected about a frozen area and then melted area and the variation of the water. So we finally we produced about permanent water water surface and the seasonal water surface for this region. And now it's easy for us to have an aerial changes, boundary of the water, but its problem is in the volume. So we are trying to use remote sensing techniques to detecting this and the depths of water. But at the moment, we are still, it is a really challenging work. We are still working on it. And for the relative differences of the depths, it can be detected. You can see some dark and some the light color. So it means the water depth is really different from 0 to 1. And you can see there is, but when we are converting it to exact and water depths, then we have a lot of problem. And for solving this problem, we are starting to collect all the water depths data by equipment-based measurement to train our model, train our, trying to use an AI technology for including all possible factors in this, and then like a black box to train it, and then finally we are trying to have some result for detecting about water depth variation. Because this is arid land, all flood water came with some clay, and then a lot of sedimentation will happen in this region. So once we are measuring this water depths by equipment, but after next flood, it is totally different. So we are still trying to develop some technology. Okay, and also we tested about a 30 meters resolution for detecting all formed and disappeared water surface and along the Tarim River. And then we also get a very good result about, and also we are trying to use some visualization and combining with some auto detection techniques to use, for example, thousands of the pictures there. Then we have to let machine to detecting all variation of these changes. And like you can see, there is some reservoir and the surface and the depths also change it. And of course, this is only for explaining about if we have a very nice index can combine, related to the Artemia related factors, then we can have a similar result like that. This is an NDVI based the animation, but if we have success to develop some index based techniques for monitoring the Artemia, it would be very useful for visualizing and also for the predicting. And this is only showing this what we are trying to do using the UAV technology for detecting about where the water gone. Actually, this is a question because it's in a rural area. It's not easy to see everywhere, and sometimes the satellite cannot pass in the same time with this period, and even sometimes there's a dust and a dust storm and so cloudy weather, then they cannot see where water gone. So we help them to use the UAV from the fixed point to check and where it's gone, and this is one of our demonstration. Okay, and there are a lot of models existed for water resources and also the water quality monitoring, and integrated with not only the remotely sensed data, but also some other data like weather data, meteorological data, and others. And our work is mostly focused on how to use remote sensing techniques, what kind of factors or parameters can be detected for the salt lake, and we can see here like several index indicated here, like an extension of the water, like an elevation, leveling of the water surface, and the volume measurement, and others. This is about what we can from the water quantity and water quality, and the several types of sensors now existed. And if we have enough money to support, and we can have a very high resolution and very high temporal resolution monitoring, and then give a very accurate data for decision makers like that. Okay, so there are several also like this. This is for ocean, actually, ocean salinity observing system. It's also given very good result. And this is one example of how chlorophyll A detection by remotely sensed data, turbidity, and this is this one. This is actually this is DOC, I think. And then we still have some gap between the application of remote sensing and with an Artemia resource monitoring or something like that. Okay, so for the future, and now everybody talking about AI, and also, and Ghent University already established one Geo-AI research center, mostly focused on how use geographical knowledge combining with AI to find some new solution to identify the necessary information from the big data, actually, and also using the cloud computing platform for the future. Okay, that's all for today, and I hope we can have a good cooperation with a specific expertise on the Artemia related the research, and then combining the remote sensing and the geospatial technology for better management and for the Artemia resource. Thank you very much. That's